Dear students, welcome to week 4, lecture 17, and our topic is understanding arrays. Students, in real world, arranging things is a very common activity. When you give a child multiple things to arrange and store, like few number of eggs or a set of crayons, his school books, etc., the child noticeably arranges the things in a single row or a single column or as a combination of rows and columns. After arranging, what does the child calls it? A tray of eggs, a box of crayons, and a stack of books. The child later realizes, oh, is it that I used an array for the job? Great! So that brings us right here to the topic. When we wish to store large amount of data in a continuous manner under a single name, we need an array for the convenience. Example, it could be storing marks of a class of students, sales record of a company, and so on. Now, let us see the formal definition of an array. An array is defined as a group of consecutive or adjacent memory locations with same name and type that stores data. Each memory location is called an element of the array, and the total number of elements put together is called the length of the array. The element of the array is accessed with a reference position number called the index or the subscript that we will see in our coming slides. Thus, to enlist the benefits, there are numerous advantages of using arrays. Arrays can store a large number of value with single name. Arrays are used to process many value easily and quickly. The value stored in an array can be stored easily, and the search process can be applied on the arrays very easily and conveniently. The different types of arrays that are available in C are one-dimensional array, two-dimensional array, and multi-dimensional array. The former two are the most widely used in common applications, whereas the multi-dimensional array finds its several applications in storing and working in pattern recognition and image storage and analysis. Now coming to one-dimensional array, when all the elements are stored in the form of a row or a columnar list, it is called as a one-dimensional array. To declare a 1D array, the syntax is, you have to first declare the data type like int or char, whatever you want, then the name of the array you wish to give, and then the size or length of the array has to be written within the square brackets. As shown in the example, we declare an array marks of type int and size 5. Initializing an array. You can either declare a blank array and later take the elements as input from the user, or you can even initialize the array by assigning values at the time of declaration. To initialize an array, the syntax is data type, name of the array, that is the identifier, then the size in square brackets, followed by an assignment operator and the list of values separated by comma enclosed within curly braces. As in the example, it is shown that we have declared an array n of type int, size 5 enclosed within the square brackets, followed by an assignment operator, and then we have assigned 5 values to it: 24, 32, 45, 56, 78, then the closing curly braces followed by a semicolon. We shall now discuss how do we access the elements of an array. Accessing individual elements is the key in data processing applications. As we have seen in slide 4, that individual elements can be referred using an index or a reference variable called subscript along with the array name. Example, we can say marks 0, which indicates the first element of the array, marks 1 refers to the second element of the array, and so on and so forth. Remember, array indices starts with 0. To access each element stored in an array, we have to use a looping control structure to iteratively run through the indices in a sequential manner, since the arrays use continuous memory location for storing the data. So referring to the example, we have an array marks of type int and size 5, and then we have a for loop for traversing through the array indices. The next statement assigns the value of I at each iteration and stores in the marks array. So the marks array now contains 0, 1, 2, 3, and 4 as the values of I at each iteration. Arrays find several applications in practice. Some of the important applications are: they are used to store a list of values, arrays are used to perform matrix operations, implement various search and sorting operations in algorithms, implement different kinds of data structures like trees, linked lists, etc. And also they are used for implementing CPU scheduling algorithms. So students, in the next class, we shall see implementing arrays in programming applications. Till then, take care, study well. Thank you.